Welcome to this presentation on Newton's laws of motion. My name is Harrison Emeka Ona from Physics and Astronomy Department, University of Nigeria, Nsukka. On this topic, the following will be discussed. Number one is the concept of Newton's laws. Secondly, the Newton's laws of motion. Thirdly, the calculations on Newton's second law of motion. And then finally, the guiding questions. Okay, the concept of Newton's laws. Newton's laws are not laws derived from mathematics. They are products of what physicists have learned from several experiments about how objects move. Newton used the ideas and observations of many scientists before him, such as Copernicus, Brahe, Kepler, and mostly Galileo Galilei, to form his laws. Here you have to understand that the Newton's laws are not laws that is derived from mathematics. They are based on the ideas and observations of many scientists that have lived before the Newton. Alright, Newton's first law of motion. Let's look at the Newton's first law of motion. And it says that a body at rest will remain at rest, and a body in motion with a constant velocity will remain in motion with a constant velocity unless it experiences a non-zero net force. Then you have an object. Here the u is equal to 0. The body remains at rest if there is no net force that is acting on it. Of course, because there is no net force that is acting on it, that object continues to remain at rest, supporting the viewpoints of the first law, that an object will still continue to remain in states of rest unless it is being acted upon by an external force. Okay, you still consider the same object. There is F net that acted upon the body, making the body to move. So without that net force that acted on that object can't move. Alright, the first law is still Newton's first law, is also known as the law of inertia. Then, what is inertia? Inertia is the resistance of a body to start moving once the body is at rest, or to stop moving once uniform motion has set. There is a measure of the mass of a body. Okay, Newton's second law. Let us look at Newton's second law. It says that rate of change in momentum is proportional to the impressed force and acts in the direction of the force. Then, mathematically, F is proportional to mv minus mu upon t. Here, the F is known as the force. The mass equals, the m is equal to the mass. The u is the initial velocity. The v is the final velocity, and the t is, of course, the time. Then you have to know that the mu is representing the initial momentum because of the initial velocity u. You have to note again that the mv is equal to the final momentum because of the final velocity v. And you have that mv minus mu will give us the change in the momentum. Okay, the F is equal to k m bracket v minus u upon t, removing the sign of proportionality. And you still have to have in mind that the k is equal to the constant, which is 1, and F is equal to m bracket v minus u upon t. So Ft is equal to mv minus mu. Here we are saying that impulse